Hi everyone, welcome back to another video, and we are continuing our series on hypothesis testing. And many of you have heard me say on multiple occasions that confidence is something that you can't just assert, you need to demonstrate with numbers. And we're going to talk about that today. So we're talking about confidence and alpha. And before we really get into this, we need to review a little bit from last time where we talked about types of error in statistics. So if we draw a little table, so if H naught, or H with the little 0 next to it, is the null hypothesis, remember that the null is the default, or what we are assuming to be true. So in our little 2x2 table, we have in the first square, up here we have if the null hypothesis is true and it is not rejected, that would be a correct claim, because the null is true and it is not rejected. This is correct. Likewise, if the null hypothesis is false and we reject it, this is also correct. We correctly rejected a false null hypothesis. And then last time we also covered types of error. So type 1 error was when we had a true null hypothesis and we rejected it anyway. So that led us to a false positive. And then over here we had if the null hypothesis was false and we did not reject it, that led us to a type 2 error. And we're not really going to talk about type 2 error today. That's not the focus. The focus today is on type 1 error because we're going to talk about alpha. So what is alpha? So alpha is the probability of getting a type 1 error, or the probability of getting a false positive with a study. So if I said that the null hypothesis was that there is no difference between the heart rates, the average heart rate of a population of college-age females, with the same group of college-age females who, ate peanut butter every single day. So if I said that there was no difference between those two groups of populations, that would be the null hypothesis. So what is the probability then that I would reject the null, that I would say that there is a significant difference between those college-age females that ate peanut butter and those who didn't with regards to their average heart rate? And if I was false in that, if I said that there was a difference, that peanut butter did make this big difference, but really, it didn't, that's a type 1 error. And so alpha is the probability of that kind of error happening. And so there's a couple things that we're going to do with this, and this is related to our confidence. So I'm going to draw out a little graph here. And so we have just a little normal distribution curve. And if you notice, I have kind of two boundaries. I have a lower boundary and an upper boundary here. And then the area of the curve between these two boundaries happens to be roughly, my drawing is bad, I apologize, but imagine that my drawing was better and that the area between these two boundaries was 95% of the area of the curve. So these two boundaries, the space and the values between the two boundaries, are the confidence interval. So this is a range of numbers that is used to estimate the true value of a population parameter. So if I said that the normal average heart rate for people is between 60 and 100 beats per minute, that could be used as our confidence interval, saying that our population average should probably be somewhere between 60 and 100 beats per minute, and that if I sampled a random population, that their average would probably fit within 60 and 100 beats per minute. So then this 95 here is going to refer to the confidence level. And so the confidence level, and this is different than the confidence interval. The confidence interval is specifically the boundaries. It is the range of the boundaries of either side. The confidence level, however, is the probability that the population mean will fall within that confidence interval. So your control group, more than likely, the control group of our study of the college-age females who did not eat the peanut butter, just odds are that they are going to end up within this area of the 95% of the graph. In this case, we're choosing our confidence level to be 95%. And the 95% is the most common confidence level to be chosen, and I'll explain why in a little bit. This can actually be flexible. Some studies will choose 80%, some will choose 99%, and that depends on what you want to do with your study. But chances are that my control group is going to fit within this confidence interval. It's also very likely that my experimental group will fit within this confidence interval, because if there's no difference between my control group and my experimental group, then the experimental group's average will fall within the confidence interval somewhere. It might not be exactly the same as the calculated average of your control group, but it's within this interval that we are confident includes the average of the population. So this is going to take us into kind of what we do with this. So 1 minus alpha is what's going to give us the confidence level. So if alpha is the probability of a type 1 error, our confidence level is 1 minus alpha. So if we take our 95% confidence level and we subtract, so if you take 1 and subtract 5%, so 0.05, you get 95%. And that's how we get this confidence level here. And that's also how we're going to get into alpha being 0.05. And alpha 0.05 is, again, the most common number chosen. And that's going to refer to the number we need to hit in order to be considered significant. So if we have a 95% confidence level, that means that there's a 5% probability of getting a type 1 error. So that would also mean that my p-value, which we'll get into later, needs to be less than alpha in order to be considered significant. So if I got a p-value of 0.002, that would be less than 0.05. That would be significant. That would be enough to reject the null hypothesis. So why would I choose a certain number over another? And this is going to depend on a few different factors, because let's say I chose a confidence level that was low. Let's say I chose 80%. So this curve, there's an 80% chance that the average of the population would fall within the 80% area of the curve. So in that case, alpha is going to be a lot higher. So you're going to have a 20% chance that it's going to be outside. So it's going to be a lot easier to prove significance in that case, because your p-value is now going to need to be less than 0.2, which is really, really high. So it's a lot easier to get a value below that. It's easier to prove significance. However, remember that alpha is also the probability of type 1 error. So if my alpha is 0.2 instead of 0.05, 0.2 is pretty high for a probability of type 1 error. So sure, if you lower your confidence level, it's easier to prove your significance, but you're increasing your risk of type 1 error. On the flip side, if I increase my confidence level, I will decrease the amount of type 1 error that I have. I'm less likely to commit this error, less likely to have a false positive. However, that means that it's going to be a lot harder to prove significance. So if I want my confidence level to be 99%, I want the average, the range here, to be 99% of this likely to have the population mean in it. That would mean that I would need a 0.01 or less p-value. in order to prove significance. That's really, really difficult. So I'm less likely to have type 1 error, but it's also going to be a lot harder to demonstrate my claim. So just know you can modify your confidence level, but just know your risk for error if you do, or remember your risk for not being able to prove that your claim is significant. So this is why confidence matters and why alpha matters. We're going to really use this later when we start talking about p-values and when we start talking about proving significance. And there are some more variables that we're going to talk about as well. We're going to talk about beta next time and power, and that's going to be related to type 2 error and the likelihood of that happening. So I know this is a little bit complicated. Stats can get a little bit confusing. I hope this made sense. Please let me know in the comments below if I need to explain things in further detail, or if you'd like even some more practice problems, I can do some practice examples of how we would use these numbers. But at the end of the day, my point was that confidence is not something that you can just assert. There are definitions associated with confidence. Confidence can be demonstrated. So if I hear somebody say that they're 90% confident in some certain claim being true, can you show me the stats or can you not? Because if you can, I'm way more likely to listen to you. However, if you're saying that you're confident in something and you can't demonstrate it, well, I'm not very inclined to believe your claim. So, I'll see you all in the next one.